Our next speaker is a roboticist, is that correct? Is Rich Walker, who's a maths and computing graduate. He set up his own company in 2009, which is called Shadow Robot. He's going to tell us how robotics can be applied to the wine trade. Possibly the idea of an automated assistant in a wine shop. Possibly the idea of a robotic sommelier. Actually, we've got those already, haven't we? We don't need any more of those. Rich, over to you.
Apologies for the fact that you're not in an audience, so I went and asked a friend what I should talk to people in the wine trade about, and he said, don't talk to them about wine, they already know about that. So I'm going to try and avoid talking to you about your own business and talk to you a little bit about what I do and how we do it.
They're having a bit of trouble hearing. You might get very close to the microphone. Thank you.
So for anybody who wants to see videos of robots, got an iPad handy, go to shadowrobot.com. Video link, click there, have a look at the videos. I'm not going to show any videos. I'm going to tell you a little bit about our company history, who we are, and what we do. So firstly, on the subject of nostalgia, I'll start with just what influences us as people who build robots. Kind of great thing about robotics is everyone knows what a robot should be like. There we are, we've got Crichton, a robot that gets sexual pleasure from doing the washing up. Marvin, a robot that gets depressed and waits 3 million years for you to come back. Gort, a robot who's capable of destroying the entire world. I always like that. I think that's a basic requirement for a piece of machinery. And Kit, probably the world's first robot who was more clever than his own owner, David Hasselhoff. Oh, indeed, David Hasselhoff. So
which one is he? Is it the one at the top?
Kit is the one at the bottom. Right. That's David Hasselhoff. The nice thing about that is it is a robot. It drives around by itself. It does things by itself. It's capable of acting on behalf of a person, but it doesn't look anything at all like a traditional robot. So that's kind of the background to where we came from as a company. We came at building robots from a fairly unusual background. We actually started as a group in 1987 as a bunch of people who wanted to build robots. It's a fairly strange thing. Most of the people we know in robotics came there because they were at university. They said, well, I'm good at this, I'll set the spin out, I've got some technology. Or they were working for a large company and said, we'll have a robotics department, we'll hire people like you to do it. We formed as effectively a club of people who enjoyed building robots. We built some kind of strange and different technologies. The devices you can see there are pneumatic muscles. These are things that behave like your own muscles. They contract and they pull something. And with that, we built humanoid robots back in the 1980s and early 90s. At a time when, as far as we knew, no one else was doing it. Now, why build a humanoid robot? Well, if a robot's going to move around in a room like this, it's got, I think, 3 choices. It can roll around on wheels on the floor, in which case it's not going to be able to get into any of the seats. It can fly, in which case when its batteries go, someone's going to be suffering. Or it can have legs, so it can step around and pass and buy things. And we figured that a robot that was going to be useful in the world would have to have legs, would have to be able to walk around. So we spent 5, 6, 7 years developing leg robots. And then Honda decided that they would announce their leg robot program. They'd spent about $100 million on a marketing project to develop leg robots because why not? Giant company. What else do you do with your spare money? Not one of my best days at work, to be honest. So we kind of went back and we looked and we said, what else can we do? What do robots need to be able to do things in the world? Moving around, that's one thing, but if you can move around, you still need to be able to do something. Kit has a driver. The driver gets out and does things for Kit effectively. And we realised that the kind of key thing to interacting with the world was a pair of hands to be able to manipulate objects. Not something that would just grip and grab in, but something that was actually capable of reaching and interacting with things. The example I always give, because I've always got one of these handy, is that's just still impossible for a robot to do. In theory, the robots we build are capable of that. In practice, we've never met anyone clever enough to write the software. In fact, our software pitch to quite a few of our customers is, well, you think you've got some clever guys, but I bet they can't solve that problem. So what we've done here is to go away and say, okay, for a robot to do something in the world, it's got to have the capability to be human. Let's try and build hands. And when we started doing that, everyone said, that'd be very difficult. We said, yeah, but if we don't try it, it's going to stay being very difficult. It wasn't as easy as we hoped. We've actually spent now 10 years building hands for robots, but they do go all over the world. We just sent one to Japan, we sold a few in China, we sold them in the US, we sold them in Germany, in France. We actually have repeat customers in Germany for some reason, I don't know what they're doing. But yeah, we're a small British company, and we sell robots all over the world to people who we would expect to be at the state of the art in robotics and things. We don't just build robot hands. One of the nice things about having an amazing showcase technology, which is what a robot hand is people come to you and they say, well, if you can do that, I have this problem over here. Could you have a look at that problem for me? So the picture on the left there is a Shakes penthouse somewhere near Boulevard Station. The designer had said, let's have furniture that moves around. That'll be a great idea. Let's have a table that comes out behind the bed and turns into a desk. And the site carpenter had said, kidding, mate, there's no one else. So they got to pretty much the end of the project build and they panicked and they phoned us up and they said, can you make us some moving furniture? I'm like, well, have a look at it. We went and we had a look and it was on the James Bond theme. I've actually never before or since seen a room that was more like a James Bond villain to there. Screens that drop down from the side, everything in white leather, ripped, unbelievably tacky and James Bond.
Gold bath taps or not? Yeah. Essential.
The other table they asked us to make was a small glass coffee table where the top would go from that height to that height. So we said, okay, how strong does it need to be? And they said, well, yeah, what do you think? And we said, fat man and hooker? And he said, yeah. I apologise if anyone here should have specified a table like that for a building, but we have to come up. That's the number here. On the right, you can see the other kind of unusual we do. This is some work with a group up at the University of Leeds who do theatre stuff. This is a performance space, and they wanted to make a robot that a dancer could dance with that would actually fill the whole room. So that's a 4.5 metre long limb that could reach down from the ceiling and sweep across the floor, but was actually safe to interact with directly. When the stage manager came to us and said, before we let dancers interact with this, you're all going to take it in turns to stand there. How do I turn it up to maximum? Like that. Okay. Right. Okay, no silent concussion for you. Software guy, you do the same thing. We went through all of us and she said, okay, that's fine. You all seem to not have concussion. I'll let you actually work with dancers. We said, why is that? He said, well, the thing about dancers, they do have very short careers. We do try not to actually break them during the degree. This is kind of bad for our industry, bad for our reputation. But doing that has led us to do some interesting follow-on projects that again we wouldn't have expected. People who talked to people who did that work went on and talked to other people, who talked to other people, and suddenly we have people coming back going, oh, we want to do a TV program, we need some technology that no one else can deliver. Could you guys have a look at that for us? Yeah, absolutely, quite happy to do that. So we've always found that very interesting, that working at one particular very challenging problem keeps opening doors for us where people come to us and say, okay, can you look at these other things for me? I put this slide up because I always like to think about trends. I'm very bad at thinking about trends. I'm doing all the time. These are ones that worry me. Not all of them are probably relevant to you, but I'll just kind of run through why these are interesting for somebody who builds robots. The first one is we're all getting less tolerant of risk. We're all much, much happier to be safe. And the nice thing about a robot is you can send the robot somewhere else instead of you. So ideally that should be able to make life safer in some way if we can work out how to do that. As roboticists, we're probably the only people who get excited about nuclear power anymore. Again, because nobody wants to go and work in nuclear power, so they want to make robots and send them in there. The other thing that we see as interesting is the change in the cost of energy. Anyone here who's over the age of 40 will remember cheap air travel. Anyone who's under the age of 40 will remember Ryanair. And there's a difference. And travel is never going to be cheap again, we think. We may go back to things like sailing ships for long distance haulage, but we're never going to see the days when it made sense to fly your hairdresser across the Atlantic to cut your hair. Different time. We'll see a couple of other interesting trends. De-aging society, the demographic slide. I think the prediction in Japan is that they will, by 2050, they will have 7 people in need of assistance for every working person. In the UK, it's more like 3 or 4 to 1 when you count children and adults. This is basically a massive, massive crisis. It may also be a massive business opportunity. I'm feeling that motorsports are well placed to exploit it. we're thinking assisted robots, robots that help people, robots in the home, robots at work. There's definitely some possibilities there. More than half the world now lives in cities. That doesn't seem to get any less likely to keep happening. I think we are basically all moving out of the countryside. In the UK, the countryside is somewhere you retire to. You make your money, buy a little stately home, you go out there, you stay there, you never come back to cities again, it seems. But in other countries, everyone's just going, well, everything's in the city. Why do we want to live in the middle of nowhere, away from people? Why don't we go and live where interest, where excitement, where fun is? So I think that's going to keep happening. Bandwidth everywhere. Again, I suspect that this conference isn't as bad as the one I was at yesterday, which was a Google conference, but I think you'll expect that the bandwidth here is being hammered and the Wi-Fi is pretty poor because I've got 2 internet-connected devices on me and I'm probably just above the average in here. We're going to see more of that. I have no idea what that's going to do for you. For me, it means I can always expect that anything I do will connect to the universe and I'll be able to get data from it. Now, I can do that. Computing, that becomes free. The cost of the computer in my pocket that I use as my main day-to-day computer, under £200. A decade ago, that level of computing horsepower would basically be unthinkable, untransportable, and that number will only ever go down. The joke about computers being given away by cereal boxes is pretty much happening. We've now got children's toys with disposable computers in, and greetings cards. Famously, a greetings card that sings is about the same computing power as one in Apollo missions. Again. Cameras and sensors. Again, everyone here has at least got a camera on them. Most phones seem to have 2 or 3 cameras. The thing that detects the light level might just be another camera. What happens when we have cameras everywhere and data from them? For people who build robots, this is really nice because we can see everything everywhere all the time. For people who collect data for marketing purposes, it's even nicer because we can see everything everywhere all the time. Graphene may not be so relevant to you guys, but for us technologists, it's the wonder substance with which everything will happen. Someone found that if you put sellotape on a pencil, peel it off, you get a new wonder material you've never seen before. It took about 200 years for someone to discover that you put sellotape on a pencil and discover a new wonder material. It's now the biggest thing in materials technology, and probably poised to change the world someday. I know it's before lunch, but I thought I'd put this one up just to give you some idea of the kind of things we're looking at with robots. The picture on the left is kind of your classic dangerous test. That's a bomb disposal robot so that's a mock-up of one of our hands on the front of it, because they never let us put one of our hands on the front of it, because the spacing of the box is covered by the International Trade and Arms Regulations, so they can't tell us. We stood there and looked and said, 70mm diameter, 8 holes equally spaced. They said we can neither confirm nor deny that fact. M8 thread, again, neither confirmed nor okay. But we've done some work in that area, looking at how you can use human-like pieces of robot technology to substitute for humans in tasks that are difficult and dangerous. On the other side, I'm a vegetarian, so I wasn't especially keen on this project, except for the sheer oddness of it, and that's meat fencing. Particularly in France, a piece of meat should be cut carefully and delicately, cutting it along the seams of the tissue. In the UK, we seem to be relatively crude about that, but this is from the French ADIF, which is the French Technical Centre for Meat. Great name for organisation. And the chap there is just carefully taking apart a carcass, and you can just about tell that he's wearing a chainmail glove and a chainmail vest. And even so, about once a month, someone slips with one of those knives. It's that big, it's so nice. So we did an entire project looking at whether we could use the robot, not to do the job, but to replace his left hand, because that's the hand that actually gets injured. And the robot showed the sensitivity and the dexterity to be able to manipulate something softer and flexible than the usual technique. We're also doing some work with other people who do dangerous things. This is the Health Protection Agency. They're called something else now, I think Public Health England. They have the same name for 5 years, so we're quite time to change. They're microbiologists. They do research on category 3 and 4 biosafety things. So this stuff is, you really don't want it coming out of those cabinets. But from time to time, glassware breaks, things, small animals bite you. And they're really, really interested in the idea that we could do things like take an egg, hold an egg to life, spot where the yolk is in the egg, drill a hole, put a syringe in, and inject the egg. So if they can do that, there's a whole bunch of products and technologies that they can adapt to make people doing these jobs I really like this slide is the second column there is the global market for milking robots. So this is, anyone here done dairy farming at any point? Big thing about dairy farming is you never go on holiday, you never get to sleep. You always are milking cows. That's basically pretty much the job spot. About 15 years ago, some guys at the University of Edinburgh doing a completely different research project finally worked out how to recognise the cow's teat reliably. They've never admitted what the research project they were doing was. I think it was an internet censorship project, but they recognised it worked out they had a piece of spam technology. And they went away and they set up a startup and they came up with a machine that the cow could walk into. And they would go, cow 7164, yes, okay, check from the scientist. And the scientist was scientist. Disinfect, apply guts, milk cow, let cow go. The cow would then go up and get milked 4 or 5 times a day, rather than twice a day. Cows absolutely love these machines. Farmers love these machines because they didn't have to get up in the morning anymore. They could take holidays. The machines work reliably. The startup company went bust because it couldn't service the machines. The companies that make these machines, they won't sell them to you if you're more than 2 hours drive away from their service centres because you can't have the system fail once you've installed it. Once your all cows are relying on this machine being there. You go out there every day and expect the machine to be there. If the machine is down, you've got about 4 hours to get it working again. What really interested me about that market is we in the robotics community, every year we take a big poll on ourselves and we say, classic Delphi study, what do we think the future looks like? What are the industries where robotics are going? Where are we going? What can we do? No one ever predicted that at all. But it's now actually the single biggest market outside medical robotics in the defence sector in the world for robots. Very, very slow. We don't show the defence sector on this graph because if we put defence robots in there, everything else vanishes. So, this is where we think robots are going to be in the future. We're going to be wrong about that. We know we are. We can maybe predict 1 or 2 years ahead, but frankly, all those things that we say, oh, there'll be no robots out there, or very few, hopefully some of those will be really interesting areas where we can take this technology. And someone like me or Mavericks, someone else will go,